Good morning. My name is Zack Densick, and like you said, the research paper I read about was about acrylonitrile butadiene styrene, or ABS. Oh, and the machine to the left, this is the actual machine in the research paper that they used. It's a Stratasys FDM 3000. The title of my research paper was Optimization of Rapid Prototyping Parameters for Production of Flexible ABS Object. The authors were Lee, Abdullah, and Khan. The research paper was published in the journal Materials Processing Technology 169 in 2005. The main scope of the research paper I read about was about analyzing certain parameters of the FDM process and to determine which process or which parameter actually gave the best to the part or um, was the most optimal for the output performance. And again, basically just kind of addressing which parameters were the most effective. Um, Again, the material was ABS. The four processes or the four conditions that they looked at were air gap, raster angle, raster width, and layer thickness, all in millimeters and degrees. And again, it was on a Stratasys FDM 3000. As you see to the right, what they did was they made a catapult, or they designed a catapult, and they put it in this fixture. And what they did was they pulled back the catapult, fired a little ball, and then determined or recorded the distances that it traveled. Uh, and they did this for every single process or every single parameter, and basically just saw which one had the most distance with each. So for the first test, they took every single parameter and they had three levels to it. As you can see, they all differ in kind of width or the size in which each one were used. So for instance, like air gap, they used a solid fine, which it was a completely solid part. For level 2, it was a very sparse part, so it was lighter, but it wasn't as durable. And then level 3 was a double wide, so it was about twice as good as the sparse part, but wasn't obviously as dense as a solid part. And they kind of used every single level in different parts. So at the bottom, after they recorded all their tests, you can kind of see it's a little kind of odd graph where all the parameters are at the bottom, and you see each level as which one gave the most distance. So the first test that they did was they used it at just 10 degrees. They pulled the catapult back just 10 degrees. And from this, they determined that the most optimal parameter combination was using air gap at level 3, raster angle at level 3, raster width at level 2, and then layer thickness at level 1. And they determined from this that the most important parameter used, or the most critical, was air gap. So what they did next was they decided to up the degrees to 15 and 20 degrees. They noticed that the exact same output or the same uh, performance for each came out, except for at the 20 degrees, instead of being A3, B3, C2, and D1, the only thing that changed was the raster width, which went to a level 3. They noticed at 15 degrees, though, that the raster angle and the layer thickness were the most contributing parameters. But in the 20-degree, they noticed that the layer thickness was the most important. So in summary, they found that they tested at 10 degrees, 15 degrees, and 20 degrees, and they noticed that the trend for all of them, or the most output performance that they could get, was at level 3 for the air gap, level 3 for the raster angle, level 2 for the raster width, and then level 1 for the layer thickness. They noticed that in overall, the layer thickness was the most contributing parameter, that the layer thickness was the most important or the most critical in every single test that they performed. My critique of it was I thought they did a really good job in terms of choosing which parameters to use and kind of just how to test, because you can do any type of testing, but I thought it was kind of interesting just kind of using a catapult and just kind of getting hard data, like stuff you can actually see with just how far a ball would go using a catapult. I thought that was kind of cool. The one thing I think that they could have done differently or kind of added to their overall test was maybe do a little bit more testing in terms of maybe like tensile testing or fatigue testing, something like that. Just it seemed that after just using a catapult, just measuring a distance, they kind of just made an assumption or kind of um, just kind of made a result. But I felt they could kind of take it a little bit farther. But that was just me.